Let me just set this code for running and I'll explain everything because the model takes time to train. Hi, so this is Onto Enricher, what I do is I take the original seed ontology and I build an LSTM model to extract concepts and relationships from text. This is the process diagram for the same. From the original seed ontology, concepts are passed and I make an original concepts list. For this concepts list, I make a Spark. For each concept in this list, I make a SparkQL request to DBpedia, Wikidata, and WordNet, and I extract synonyms, hyponyms, and hypernyms for each of these concepts. That is stored in my training dataset, and the original concepts also go into my training dataset. So ultimately, the training dataset looks somewhat like this. So, for example, policy is my concept which came from the original. Let me just set this code for running and I'll explain everything because the model takes time to train. Hi, so this is Onto Enricher, what I do is I take the original seed ontology and I build an LSTM model to extract concepts and relationships from. They are not related to security domain. This is done to ensure that our model only extracts relations which are related to security domain. We'll explain more on that later, but yeah, this is the format of the training corpus dataset. Uh, like there are some other synonyms, for example, cryptographic hash function and modification detection uh, code. So these two are synonyms of each other. Cryptography and cryptographia are synonyms of each other. Uh, Cryptography and decryption are synonyms. Uh, Stream cipher and self-synchronizing cipher are synonyms. So like that. Uh, this has been validated by a domain expert. So there's not much to show here. But the next thing would be to talk about the training corpus. The training corpus contains articles from the Wikidump which have titles that are one of the concepts, that are one of these concepts. So, for example, it would contain articles related to document, it would contain articles related to organization, um, and so on, like magnetic tape and asset, firewall, switch, virus, all of this, right? And this goes into my LSTM, and so do the training dataset. So the LSTM, what it does is it takes the training corpus and it learns the weights between each relation, uh, between each noun phrase in the corpus. How does it learn these weights? Using the dataset. So, for example, uh, the wiki article would be something like affirmative action is a policy in the United States. So affirmative action and policy are two separate noun phrases, and it will give these concepts a lower weight because none has been marked here. Suppose if it were marked as, say, hypernym. So system is a policy, for example, or Carter doctrine is a policy. Then it will give it policy is Carter doctrine or something like that. So then it will give it a higher weight. It will give this hyponym a higher weight as compared to other relationships in the other noun phrases in the same sentence. And not only will it give a higher weight, this will be my label. Hyponym will be my label. Uh, Once that is done, the next step would be to train a model. The model trains on this and uses an integrated approach, path-based plus distributional. Path-based in the sense that it takes the noun phrases in the sentence and constructs relationships between every noun phrase, gives higher weights to the ones in the dataset, gives lower weights to the ones not in the dataset, and lower weights to also the ones which are marked as done. And ultimately it learns the structure of the sentence, right? So if it says that A is a B, then A is most likely a hypernym of B, or B is the same as A, then it learns that B is a synonym of A. So that is what we are going for. Then next, this train model is built. Train model is tested using a web corpus. Any web page will do. We give it, and all the concepts are extracted using all the noun phrases are extracted using a simple regex parser. We feed it as input to the train model. It classifies them as synonyms, hyponyms, or hypernyms, or none. Once that is done, we take these relations, the non-none relations, and give it to OntoViewer, which is our ontology visualization and validation tool. Hopefully the code should have run by now. No, it's still running. Since the video is going long, I'll show the result directly. The result is we got 82% accuracy on this. So this is the result. So what it does is, this is my testing data set which I built from the web page. The none is the third in word in each sentence is the correct relation. The fourth word is the predicted by the model, right? So for example, malcode worm, this was predicted wrongly by the model. Or for example, malware is a Trojan, right? So this was predicted rightly by the model. And or for example, crimeware is a Trojan, that was again predicted rightly by the model. Or rootkits are a Trojan, so again rightly predicted. So if you observe, most of these are none, and that is because we did an NC2 of all the noun phrases in that word. So it makes sense that most of these would not be related, but only some of these would be related. We did an NC2 because we wanted a combination of not an NC2 of all the noun phrases, by the way, an NC2 of noun phrases which are there nearby. So we built pairs basically, and which are there in the same paragraph, and we did that, and this is what the results are. So we take the non-none relationships and we pass it to the OntoViewer.
So this is a demo for OntoViewer. For this purpose, we have two dummy Twitter accounts. One is in incognito mode, as you can see. The other is in non-incognito mode. So this particular Twitter account is an expert in pizza. So all his tweets are in related to pizza, as you can see. And the other account is an expert in security. This is in non-incognito, and this is a security expert. As you can see, these are related to security. So we will so these two accounts will be reviewing our pizza ontology. So any decision by pizza expert has to have more priority than any decision by security expert, because we are reviewing a pizza ontology. So we will do that. So this is the login page of our application. Anyone can sign in with their Twitter account. Since these Twitter accounts are already logged in, we are getting a request to authorize the app, which is our OntoViewer app. So we will be doing that. So we are selecting the pizza ontology. So anything that is green color and green color in relationships are newly added relations. and newly added nodes. All blue are existing seed ontologies. So these are seed ontologies, and these are non-seed, like these are newly added nodes and relationships. Uh, uh, so these two guys are reviewing the same ontology, so they accept or reject any relationship. So since these are the new relations which are highlighted in green, the expert can choose to delete some relationships. So an important thing to remember, so that you can rewind it later, is that this in incognito, as you already said, the pizza expert is in incognito mode. So he accepts this relationship, which is a relationship between peri-peri and pizza. The relationship is hypernym. So he accepts this. So he accepts this relationship, and he rejects a relationship between tandoori pizza and Indian pizza, which is same as. So he rejects. On the other hand, the security expert does the opposite. So he actually rejects the relationship between peri-peri and pizza. The relationship is hypernym. So he rejects this, and he accepts the relationship between tandoori pizza and Indian pizza, which is same as. So ideally, the decisions by the pizza expert which are in incognito mode have to take prevalence, and those should be reflected. So we will test that functionality of ours. So this particular file takes in a large dataset and analyzes the tweets of both the users and gives them a credibility score from a large dataset that we have already trained. And once we get the weights, we will generate a new final ontology which has these relationships as reflected. So this code takes 2 minutes, so we will wait till that time. So the dataset that currently being analyzed is around 4 GB, so it's taking around 2 minutes for that. So we pass some keywords like pizza and all for to analyze this. So the final ontology is generated, and we will run this ontology on WebVol, which is a web-based ontology visualization tool. So in this UI, you can give files in any of this format. We will give in a custom format of our file called .old file, and you can have a search functionality here where you can search the node you want to search. So now we will upload. So the final ontology is generated here. As you can see, it's just generated now. So the final ideally the final ontology should have the decisions of the pizza expert preceded over the decisions of the security expert. So we will see whether that's the case. So so one of our relation is peri-peri to pizza. So as you can see, peri-peri is here and the relationship is still intact because the pizza expert accepted this relation, while the relationship between Indian pizza and tandoori pizza is completely absent because it was rejected by the pizza expert, while the security expert has done the opposite cases. So this is the final demo of Onto here.